Neville Ash is, it is very short already. Neville Ash is Chief of UNEP's Biodiversity and Ecosystem Services branch based in Nairobi. He oversees a range of science policy initiatives and leads on the development of the International Platform on Biodiversity and Ecosystem Services, IPBES. Previously, he was head of IUCN's Ecosystem Management Program, providing leadership for IUCN on climate across a variety of biodiversity issues, with a focus on the interactions between global change, ecosystems, and people. Formerly, Neville was also head of the ecosystem assessment at UNEP WCMC, working on a range of international assessment and partnership initiatives and focusing on trends in global biodiversity and the consequences of biodiversity change for people. He also has worked on wildlife trade issues and spent time researching and managing species conservation initiatives in Africa and Asia. He is a former co-chair and current member of the Diversitas Biodiscovery Science Committee. So very impressive CVs, and I would like to ask him to give his kickoff statement.
Thank you very much, Stefan, and good afternoon, everybody. As we've seen over the last couple of days here at the conference, there is a consensus on a number of issues in the scientific community. These include that the threats to our sustainability are being undermined by growing pressures on ecosystems, on socio-ecological linked systems. We're seeing growing pressures on biodiversity from climate change, from invasive species, from the overexploitation of species and their habitats, from habitat loss, and from pollution. And as a result of this, we see a degradation in the world's systems, the world's ecosystems, and an undermining of their ability to provide the benefits on which people depend for their livelihoods and well-being. But a number of people have done very well out of this, that the degradation of ecosystems for the extraction of ecosystem goods, timber, food, fuel, has benefited a large proportion of the world's population at a cost of undermining that longer-term sustainability. And the most recent study, which gave an overall picture of the situation, was the Millennium Ecosystem Assessment, which in 2005, so now 7 years ago, came to the conclusion that around 60% of ecosystem services were being used unsustainably or being degraded. Typically, it found that the trade-off was between the provisioning services, the goods that we're extracting from the world's ecosystems, and the regulating, cultural, and supporting services, which underpin the sustainability of provision of other services. And so what's needed is essentially, we've heard a lot about the word transformation in the last few days as well, a transformation of sustainability. If we are to meet more of the Millennium Development Goals, to which we are making some progress at the moment, if we are to meet a post-2015 development agenda which is now being discussed, if we are to make progress towards the outcomes of the Rio+20 summit earlier this year, and towards the so-called green economy going forwards, then a transformation is needed, because business as usual and the scenarios we see coming out of the scientific community and policy community, developing many scenarios as well, do not show good progress unless we achieve such a transformation. But that transformation needs to be underpinned by science. It is critical if we are to know, if we are to proactively engage in different policies, different decisions relating to a transformation for sustainability, that we base those on science. And so I think the first challenge to the scientific community is, are we producing policy-relevant science that can underpin such a transformation? And such a transformation may not need to be complicated. It is not always a polarized debate. If we look at the sustainability in food production, for example, we hear a lot about whether we need to go down an organic route, an LMO, GMO route. Probably the answer is neither. It is something in the middle. There was a great study that came out very recently in PLOS ONE, looking Iowa State University, US Department of Agriculture, and others. A very simple experiment. Over an 8-year period from 2003, it looked at 22 acres in Iowa State University land and did a very simple three-approached experiment. The first was to put in place a 2-year rotation of corn and soybean, and look at the typical production coming out of a corn and soybean production system with the application of herbicides, fertilizers, and so on. A second plot introduced a third-year rotation and included oats in the mix. And then a third plot introduced a 4-year rotation with the corn, soybean, oats, and alfalfa. And both of the longer-term rotations then introduced livestock into the system as well, for which we're providing manure for the fertilizer and which were being fed off the animal feed stocks, animal feed produce being produced in that system. And what was found is in those longer-term cycles, the 3- and 4-year cycles, the productivity of corn and soybean increased dramatically with a reduced need for inputs of nitrogen fertilizer and of herbicides. And crucially, the profit from those three systems remained constant. So there was no net loss in profit from those three systems, but an increased productivity in corn and soybean and reduced input for the longer rotation periods. A very simple, very policy-relevant experiment, which came to a very, one might argue, obvious conclusion, that one can have less inputs, although the human input, the work capital required was greater, but the profit remained the same. So essentially you're paying people salaries rather than paying for fertilizers and for herbicides, with enormous environmental benefits. So the toxins in the groundwater relating to those three sites dropped dramatically between the shorter to the longer term rotations. So there are some very simple solutions which the science is already there to underpin, which we need to scale up beyond 22 acres in Iowa. So first challenge, are we producing policy-relevant science? And then the second challenge I think we face is are we communicating that science appropriately to decision makers? And are we doing so in a way which is understandable? If I was allowed to show any PowerPoints today, I would have just put one slide up. And many of you may have seen this before. It's a little cartoon that has a scientist showing some uncertainty ranges and the politician turning to them and saying, can you tell me that in really unambiguous, very clear, simple terms? What's going to happen? Is it black or is it white? Is it organic? Is it GMO? And we know the answer is not so simple. And anyone in doubt of that, of course, needs to look no further than the recent judgment in Italy over the 6 seismologists who were convicted on appeal at the moment, but convicted over not failing to predict the earthquake in L'Aquila in 2009, but failing to predict the risk of the earthquake in 2009. And so we have to do a much better job as a scientific community in communicating to decision makers our knowledge, our certainty, and our uncertainty relating to the science coming out of our work. And so the second challenge, are we communicating the science we are producing appropriately to decision makers? And the science policy interface, particularly around sustainability science, biodiversity and ecosystem services, I think has been strengthened recently in April of this year. The Intergovernmental Platform on Biodiversity and Ecosystem Services was established by 94 governments. And essentially it's aiming to fill a gap which has existed for a long time in the ecological and socio-ecological science policy interface. In the climate science community and decision-making community, the IPCC has acted in this function in considering, reviewing, and making available climate science in a format and a manner appropriate to the decision-making community on climate change. But we've missed that on the broader environmental set of issues. And I think IPBES, the Intergovernmental Platform on Biodiversity and Ecosystem Services, will play some role in supporting that science policy interface. And so the third challenge I want to leave you with on this introductory statement is how, as a scientific community, we can ensure strong participation in IPBES. In the same way that many thousands of scientists are involved in the IPCC, we need to ensure that many thousands of scientists are involved in IPBES to ensure, as we heard this morning, it is credible, it is legitimate, and of course it is responding to the needs of decision makers, therefore it is salient or it is relevant to the policymakers' needs. So 3 challenges: are we producing the right science? Are we communicating it well? And to support those, can we get involved in IPBES and make sure that is successful in meeting some of the needs for getting science into policy processes, recognizing that science is, of course, only one part of a decision maker's portfolio of inputs when it comes to decision making, and it's competing often with political will, lobby groups, and other interests. So some challenges to the scientific community.